Okay, so this is the third video for systems of equations, and we're just going to look at the substitution method. And so your job or I can statement is to solve two equation systems through substitution. So we've looked at the graphing method as a way of determining where the lines intersect. Now we're going to look at a way that doesn't require graphing at all. The graphing method could be used to check the solution, but it's not necessarily demanded. So here's some steps in words. If you're, I know people learn in different ways, right? So if you like to have steps written down in words, these are some that I've made up for you. Solve one of the equations for y or x. Second step, substitute for y or x and then solve for one variable. Final step, use that variable's value in the other equation to solve for the other variable. Now, it's difficult to understand what these steps mean without an example, so that's where we're going to go next. But if you need to copy them down, feel free to pause. Okay, so the first thing we wanted to do was to solve one of the equations for y or x. I'm in the habit of solving for y because that's what we normally do, right, to graph. So that's what I'm going to do here. You can see that, let me change this to my pen. You can see over here in this equation, 6x plus 6y equals negative 6. We could divide out a 6 from everything, but that's not going to help us necessarily solve for y. So let's wait to divide by 6 till we get y by itself, or we could do it first. It's up to you guys, but we wouldn't want to distribute 6 on this side. We'd want to divide everything by 6, or factor out 6 on this side is what I meant to say, not to distribute it out. But let's start by just getting y by itself as 6y by itself. And now we can divide everything by 6. Like I said before, you could have done that first. Doesn't really matter. So we get y equals negative x minus 1. Okay, the next step is to substitute in what it says y is equal to. So notice this is a mathematical statement. It says that y is equal to negative x minus 1. So what I can do is I can plug that in for this y value here. And let me change my color to red here so this makes a little more sense to you. Change back to blue now. But notice what I've done here is I've inserted what this equation says y is into this y. So this y became negative x minus 1 because this equation told us that's what y is equal to. And so the next step, and I'm just going to go all blue now, is to solve for the one variable we have left, which is x. So I put it in parentheses just to make it more obvious of my insertion here, but we really didn't need to use parentheses. So this is 5x plus a negative x, or 4x total, minus 1 equals negative 13. So 4x equals, and I have to move my negative 1 to the other side here, negative 12. And so x equals negative 3, because we divide both sides by the 4 here. And so by solving just for this one x in this equation, it tells us that x is negative 3. Now, I take this negative 3 and plug it into my original equation up here and solve for y. I could plug it in here for this y, or into this more simplified equation, but the reason I choose to go back to the original is just in case I made a mistake along the way. I like to go back to the original. So I'm going to rewrite the original equation over here. 6x plus 6y equals, negative 6. So I'm going to insert the x value now. This becomes 6 times negative 3 plus 6y equals negative 6. So we get a negative 18 plus 6y equals negative 6. I'm going to move this over here. So 6y equals, let's see, this is going to become a positive 18 on the other side, right? So that's going to be a 12. And so y must equal 2. So I come up with a solution set here with an x of negative 3 and a y value of 2. I'm going to go to the next slide here and copy that down. Negative 3, 2. I'm not quite done yet, though. Let me quickly recap, though, before I go to the next step. So what I did here was I first solved one equation for a variable, in this case y. I inserted what it said y was equal to into the other equation to get rid of the variable of y. And now you notice at this point right here, I'm down to one variable, just x's. So I can easily solve for x. Once I have the value of x, I can then insert it into my original equation, my other original equation, right up here, which I copied down right here, and solve for the other variable of y. Then I kind of have a solution set here. Okay, -3, 2. That's what it's telling me the solution is. But I never want to move on until I've checked my solution. So let me copy down both equations. 6x plus 6y equals -6. My pen works here. Oop. Come on, pen. There you go. And then the other equation of 5x plus y equals -13. And then I want to insert both of these values in and see if both statements are true. I'm going to check this solution just like I did in the graphing method. I always want to check my math. So in this case, x is -3. So I insert that for x, and y is 2. Right? And I'm going to assert over here, 5 times the x value plus the y value is -13. Let's see if this works. And as we can see, it does indeed work for the equation over here on the left. And let's see if it works for the one here on the right. And obviously it does. That's nice. -13 does equal -13. So because, with the insertion of these values into both equations, because that led to 2 true statements, I know for sure that this is a solution for this equation and this equation, which I know right off the bat are straight lines because x is to the power of 1, and there's an x and a y. So that's just one example of how to use substitution. I hope I didn't go too fast. If I did, please feel free to rewind, or like I said in the previous video, shoot me a message there on the home screen of the website, and I'd be happy to give you another example or answer any questions you have. Thanks.